Welcome to the weekly developer log for Sonic Entropy. Today, we'll be going over the work completed for week 2 of our Sonic fan game that's being built from the ground up in a completely custom engine with custom graphics, physics, and a built-in level editor to try and bring you the ultimate Sonic Boost formula experience. If this is your first time here, well, you should probably go watch these from the start, right? Just pause the video and come back when you're all caught up. But if you've seen this before, or if you're as stubborn as I am, then hello. I'm Blitzy, and I'll be guiding you through this video. However, if you see a black and purple Fox Mobian on screen, that's my wife Pagan. She's the lead and currently only developer for our game. I, on the other hand, handle all the creative stuff like the story, the art, and the marketing. So, with that out of the way, let's get into this week's devlog. Pagan started stream on Monday by adding some quality of life features to the code base, such as code that quickly allows for specifying colors using hex codes, and then she moved on to creating a system that allows you to click and drag selected objects along the grid. This started off smoothly. She added a system that highlights a box around all selected objects, and then added in code to detect click and drag events. The problem started when she added the code to move boxes. Turns out you need to remember where the objects were before you started moving them so you can accurately figure out where the objects should snap to based on mouse movement. But if every object is unique inside of a level, how do we create a copy that is the same object but contains previous information about it? The answer she found was in using something called runtime pools, which is a system in NTT that allows you to create additional copies of components which are accessed by a name rather than the component type itself. The documentation for this wasn't particularly helpful with how sparse for information it was, so she ran into numerous issues like compile time errors stopping her code from working. Then, when she did manage to get the code to compile, she ran into runtime errors, which shouldn't even be possible with the system that she was using. But she finally managed to work her way around all of this in the end. As it turns out, when you add something to a runtime pool, a pool is automatically created if it didn't previously exist, so you never really need to technically declare it in the first place. That is, unless you want to read data from a runtime pool. Then you are required to declare that it exists, otherwise it will throw the digital equivalent of a temper tantrum. In the end, she managed to be able to move the selected objects around and was finally able to commit that code to GitHub, which took around 3 hours. She ended the stream just before midnight, feeling drained and ready to go to bed, which she did, right? She did not go to bed. Instead, she found a bug where if you accidentally lose focus of the Cyclone level editor window while still dragging objects, those objects will snap in weird ways. She also fixed some memory leaks, where some GPU resources weren't being destroyed correctly when closing the program. Except technically, that doesn't count as a memory leak? It should have been fine since Windows does clean up any leftover resources automatically, but it's always a good idea to make sure your code does these things itself without having to rely on Microsoft doing it for you. Finally, at 4 AM, just before she went to bed, Pagan added in a much nicer looking toolbar which now has the 3 snapping modes fully selectable. Those being Snap to Grid, Snap by Grid, and ignoring the grid entirely. Tuesday, I decided to stream. I didn't do anything specifically in relation to the project, but I did do some art on stream, which helped with my confidence in drawing characters more consistently while establishing an understanding of how to use 3D models in Clip Studio Paint in order to help with elements like hands, for example, that help speed up the workflow in areas where I might not be as confident. This will make doing promotional work and storyboarding easier in the long run because the more I understand the character proportions, specific rendering techniques, and the tools at my disposal, the easier it'll be to accomplish the art-related tasks that are going to be falling into my lap over the course of this project. Even so, Pagan decided to do a little bit more work in the background. When you build software with C++, you usually organize different parts of the code into classes, where each class is used to create an object that contains some data and provides some functionality. The user interface for Cyclone is managed by a few different classes, but the important data is fully contained inside one big class. This isn't very good practice because you ideally want to split things up into smaller, reusable modules that are easier to manage. So while I was preoccupied with drawing for stream, Pagan started moving some data out of the big class into smaller classes to better encapsulate things. This doesn't really change the functionality of Cyclone in any way, but it does make things easier to manage when it comes to adding new features or changing the way existing things behave. During Pagan's Thursday stream, she continued to split Cyclone's code into multiple smaller, more organized chunks by making the codebase less monolithic and more modular. While there isn't really much to talk about in terms of specifics of what she did, something interesting to note is that she managed to reduce the number of lines of code in one file from 700 down to only 200. After stream, Pagan explained that she finally made peace with the fact that progress doesn't always need to be defined in terms of features added. Progress can also be made by planning how to do things in the future and by updating existing code to make future progress easier. So in essence, during Pagan's stream, nothing technically changed about how Cyclone works. The user interface remained identical and all existing features remained unchanged, but by reorganizing the code, she made things easier to work with for future streams. In Friday's stream, Pagan planned to add the ability to select objects in the 2D viewport using the mouse. Although we're working with the 2D viewport here, technically all the objects are still in 3D, or just looking at it through an isometric perspective. In order to detect which objects are under the mouse when we click on something, we have to do something called a bounding box intersection click. Every object is surrounded by a cube called a bounding box, and whenever we click in the 2D viewport, we create another bounding box around the mouse's position, which is only a few pixels wide but spans the entire depth of the world. We can then check if the bounding box of an object overlaps with the bounding box created for the mouse. The math for this should be simple, but you need to remember that levels may contain thousands of objects, and as the number of objects increases, so does the cost of performing these checks. So rather than taking the easy way out and telling people to just get a better PC when things begin to lag, Pagan decided to write some code that utilizes specific CPU instruction to do these checks in the most efficient way possible. After integrating the code and testing that it works, she discovered that there's more to clicking on objects than math alone. For example, if one object is directly in front of another, how do we determine which one to pick? Do we pick the one in front, the one behind, the one we check first for intersection? Or do we want to do something more sophisticated, like switching between which object is selected over multiple clicks? This gave Pagan some food for thought, and she decided to explore which feels most intuitive off-stream through experimentation. Maybe some rest would help. Come back to it with fresh eyes in the morning. Spend some time solving the problem without the added pressure of stream or chat or the fact that we need to go to bed soon. It is midnight after all. Let's get some shut-eye and finish this in the morning while Blitzy edits a video. You looked at the timestamp of the video, didn't you? And a better question, why is it 5:30 a.m.? I mean, it's in the video you're watching right now. Look at the right-hand corner of the screen. It is actually 5:30 a.m. and I'm having a hard time writing this out for the bit. Okay, this is getting a bit too meta. Back to the update. Okay, fine. So, yet again, rather than going to bed, she ended up solving that problem immediately. Every object in the level has a unique numerical ID. Whenever you click within the viewport, a list of all potential objects is stored within a candidate list, and then the object with the smallest ID number is chosen as the selected object. But if you click a second time and the new candidate list is identical to the previous candidate list, we will instead select the object with the next largest ID. We can keep repeating this until the object with the absolute largest ID is selected, after which we will wrap back around to the smallest one. This also works with deselecting objects. If multiple objects are underneath the mouse while pressing the control key to deselect, we'll start with deselecting the smallest ID. We'll call this control clicking. But then here's where the magic happens. Pagan somehow, and I really do mean somehow because she doesn't even know how to explain this, found a way to make it so when repeatedly control clicking in the same spot, it cycles through every possible combination of selected and deselected objects. She doesn't recommend you do this for many overlapping objects though. Instead, just use the entity list on the right-hand sidebar to deselect objects instead. From now on, we will call that the outliner. Because say for example, you had 52 overlapping objects in the exact same location. You're not gonna get the one you want. The heat death of the universe would arrive before you cycled through every combination of selected objects. But it works, and that's the most important part. And that about does it for this week's round of updates. If you missed last week's video, click here to go back to the playlist where you can find all of our current and future devlog entries. And of course, if you want to stay informed, consider subscribing so you can catch all the latest updates every week, and drop a like if you felt this video was informative or enjoyable in any way. It helps the project get recommended to more people. Thanks for watching, and we'll be back with more news next week.